Welcome, dear students, to your Masterclass by Medicoapps. I'm Dr. Mohammed Sarosh. We're continuing with the statistics and very important concept and questions asked in normal distribution and skew distribution curves. Okay, let's learn this. Okay, so first let us take a white page and learn about what is normal distribution curve. Okay, so if you take a graph page and you plot all the weight in your classroom. For example, you consider you have 200 students in your class and you take the measurement of everyone. You will have like more of them, like for example, consider like 50 is a mean or average weight, and many of them will be in the like half of them will be in the lower side and half of them will be in the higher side. So half of them will be in higher side, half of them will be in the lower side than the average, isn't it? So this is how, or if you keep on plotting the student 1, student 2, like that, student 100, you have a graph which comes like a bell shape. It's like a bell shape, symmetrical. Okay, sorry, and symmetrical, and you have this called as normal distribution curve. Okay, and there's some values. Okay, for example, the closer to the average, if you include the 68% of the people, that will be mean plus or minus 1 standard deviation. Remember this. And if you want to include like almost like 95% of the students, then it would be including mean plus or minus 2 standard deviation. I'll write it here. Okay, and then if you want to include majority of them in your study, it will be mean plus or minus 3 standard deviation. That will be the entire uh, coverage of of that classroom. Okay, so these are some values you need to remember for normal distribution curve. So let's learn simply. Okay, like if you plot the weight of all the students, okay, and you have the average here, so it will be like 50% will be lying on the right side, 50% will be lying on the left side of the mean or average. And in the normal Gaussian or standard distribution curve, you have equal here, so therefore the mean, median and mode, all three will be equal. Okay, and if you consider for a normal entire infinite population, the mean is taken as 0, okay, and the standard deviation is taken as 1. Remember this as a question. So okay, so the features is a symmetrical bell-shaped curve where all these three coincides, and there's infinite variables or values there. Okay, yeah. So like I shared, the coverage of from one here would be mean plus or minus 1 standard deviation. For this will be mean plus or minus 2 standard deviation. Like mean is 50 kgs, right? Plus or minus 3 standard deviation. This will be the coverage covering this many students if you take this much of population, right? This is, and this one standard deviation is how much? It was 68%. 2 standard deviation is 95%, and 3 standard deviation will include 99%, majority of them. The remaining 1% like 0.5 will be on either side of the mean end of the graphs. Okay, so that's what it is showing here also. Okay, so now the questions are based on this, okay, on this concept. So if there are 100 students and mean is 60 kgs weight, standard deviation is given as 5 kgs. So the question is how many students, 95 students will have what range? So for that, 95 students के लिए you have mean plus or minus 2 standard deviation formula. Just enter the mean, that is 60 kgs here. Standard deviation also that is 5 kgs, and when you enter that, you have here as 60 plus 5 to the 10, or 60 minus 10, plus or minus, remember, so we have 70 and 50, so it will be, the range would be 50 to 70, like that. So the answer is 50. The weight of them will be 50 to 70 kgs. Similarly, they can ask you other question, that is 68%, mean plus or minus 1 standard deviation. Okay, when you enter the values, you get 55 to 65 kgs. 99%, yes, mean plus or minus 3 standard deviation, and the values you get answer is 45 to 75 when you put that. And fourth question is a very different one, which says how many students will have the weight more than 60. If that is asked, you can just refer the graph that I showed in the beginning. This is already, we know that this is mean, that is 60 kgs, right? So we know 50% of them will be more than this, 50% will be less than this. They're just asking how many will be more, 50%. There's a concept called point of inflection, wherein this is the point where it could be like flattened, or it could be concave, or it could be convex. Normal distribution always dumb like bell shape or convex, remember. Okay, so if you see, the value here is 1 standard deviation, plus or minus 1 standard deviation. Mean plus or minus 1 standard deviation would be the coverage of point of inflection. Okay, yes. Now let's talk about the skewed distribution. Skewing, like moving away from the normal. Okay, either it is on the right side or it is on the left side. Okay, so you have right side or left side. So normal would be like, we just imagine this would be normal. Okay, so if there are more values here, so it will be like skewed on the right side. Same graph will look like this. And similarly, if it's more on the left side, you have like more here and less here. This will be the left skewed, like this, more on the left side. Okay, so for example, majority of the school, if they have very high marks, so that will be the right skewed. That is, more of the students are having more marks on the right side. So here the mean will be more because the maximum score will be more, right? So mean will be more than mode when you compare the three. In the opposite way, we have here the left skewed, wherein many students fails, for example. Okay, for that kind of situation, we say it is left skewed or negatively skewed. Towards the left side, they are more values. Okay, and then the also it gets reversed, which is more valuable here is mode, which is having more than the mean than the median also. Okay. All right, so I think you're not able to see area of this, so don't worry. Okay, Poisson's distribution. Okay, here also you see the same thing. It's about the skewness. So this is a normal one. Either it's negatively skewed or the positively skewed. Number of events that are expressed in the unit time is Poisson's distribution. For example, number of OPDs, if we measure per day, it will give that distribution. I hope this was a bit understandable. Thank you so much for listening. See you in the next class.